Hello again, everyone. In this video, we're going to be taking a look at a pretty big concept in both geometry and algebra, and that is how you can graph a linear equation. This is something that you should have done quite a bit in Algebra 1. Maybe need to refresh your memory on it a little bit, and make sure you have a pretty good handle on this going into Algebra 2 next year. So let's take a quick look first. A little review from algebra. If I have an equation like this, 2x minus 5 equals 19. How many possible solutions does an equation like this have? And so we look at that. One of the things we notice is that there's only one variable in this equation. And an equation with only one variable, there's kind of a limited number of possibilities in terms of a solution for that. Either there are infinitely many, or there are no solutions, or it's possible that there's just one. And actually, that's probably what happens most of the time, right? There's one specific number that we can put in for a variable and get an equation that's true on both sides of the equal sign. And that's the case here, right? I can do a quick solving of this by adding 5 to both sides and getting 2x equals 24, and then have divide by 2 on both sides and get x equals 12. 12 is the only number that I could plug in for x and have the left side of that original equation equal the right side. And that's because there's one variable there, and it's not one of the kind of unique situations where there's no solution or where there's infinitely many. But now if we come down here to this next equation, and I look at this one, it says 4x plus y equals 8. It says, how many solutions does this equation have? Well, this is a different animal, right? We don't just have one variable like we did up here. We have two. We have x and y. And this is where things can kind of get a little bit maybe more complicated. Because if I think about what possible numbers I can put in for x and y here that would make the left side equal 8, or equal what the right side says, I can think of a lot of possibilities, right? I can put a 1 for x, so 4 times 1 plus a 4 would give me 8. So x equal 1 and y equal 4, that's a possibility. I could put a 2 in for x, 4 times 2 plus, and then use 0 for y. That would equal 8. So x equals 2 and y equals 0 would be a solution. I could keep going. I could use maybe some fractions, I could use some negative numbers, I could use some decimals, and I could just keep listing out pairs. So there are infinitely many solutions to this equation that has two variables in it, right? So if there's infinitely many solutions, how do we represent what the solutions are? And that's where graphing equations comes in, because a graph of an equation is a way that you could represent what possible solutions something like this has. Let's take a look why. So I have a table here, and I want to list out some of the equations, some of the solutions to this equation that I could come up with. Now I already have two, right? An x value of 1 and a y value of 4 works in that equation. And an x value of 2 and a y value of 0 also works in that equation. Let's see if we can think of some more. If I put 0 in for x, that would be 4 times 0 plus something, giving me 8. Well, 4 times 0 is 0, so what would I need to add to that? I would need to add an 8, right? So if 0 is my x, then I can put an 8 in for my y. I could maybe start using some negative numbers, right? I could let's say I put in a negative 1 for x. So I'd have 4 times negative 1 plus something equaling 8. Well, 4 times negative 1 is negative 4. And if I'm going to add something to negative 4 and get 8, I would have to add a 12, right? 12 plus negative 4 would give me 8. So I could have negative 1, 12. Let's see, what else could I put in? What if I had what if I used a decimal or a fraction, right? What if I put a 1/2 in for my x? So 4 times 1/2 plus what would give me an 8? Well, 4 times 1/2, or half of 4, would be a 2. What do I add to 2 to get 8? That would be a 6, right? So I could have 1/2 comma 6. What if I tried another fraction? What if I tried a 1/4? 4 times 1/4 plus what would give me 8? Well, 4 times 1/4, or 1/4 of 4, is a 1. 1 plus 7 would give me 8. So I'd have a 7 there paired with my x value of 1/4. Now if I look at all these are all pairs of x's and y's. And pairs of x's and y's makes me think of a coordinate plane where I put points on there, and each point is a representation of an x value and a y value. So let's plot all of these on the coordinate plane. 1, 4 would be right there. 2, 0 would be right there. 0, 8 is up here. -1, 12. Well, I'm off the graph a little bit there. I can't fit that one on there, but it's somewhere, it's somewhere up in this region right up here. 1/2, 6. So 1/2 would be at 6. So that looks like it would be right about there. 1/4 would be at 7. So just barely past the y-axis. I'm up here at 7. So that looks like it would be right there. And what I should start noticing is those points all look like they're kind of lined up. In fact, if I went ahead and connected all those points, I should be able to, now again, we have my limitations in drawing on my computer pad here, but if I connect all those points, I should end up with something that's a straight line. And again, I'm not going to be able to draw the most straight line in the world here, but you get the idea, right? If I connect all those points, if I had a ruler that I could slap on my computer screen here and connect those points, they should all line up perfectly in a nice straight line. And why is that? Well, this is an example of a linear equation. It's an equation whose solutions, when plotted on a coordinate plane, end up making a line. And this line represents all the possible solutions to this equation. Anywhere I would put my pen or my pencil on that line, whatever the coordinates of this point right here are, which looks to be about 1 point something, 2 point something, that specific coordinate, 1 point something, 2 point something, that ends up being a solution that works in 4x plus y equals 8, this equation that I was working with, right? So the graph of a linear equation is a representation of all the possible solutions to that equation. There are infinitely many because there are infinitely many points on a line. We learned that way back at the beginning of geometry, right? There are infinitely many points on this line, which fits the fact that there are infinitely many solutions to the equation that it comes from. So that takes us to this idea of the standard form of a linear equation. The graph of any equation that can be written in the form ax plus by equals c, where a and b are not both 0, is a line. So any equation, just pick out some numbers for a, b, and c. Just make sure both a and b are not 0. So 2x plus -3 times y equals 12, or I guess that would usually be written as 2x minus 3y equals 12. That thing's graph is a line. -x plus 7y equals 1/2. That thing's equation is a line. I can put some zeros in. If I put a 0 in for x plus 3y equals 12, well, the 0x would just go away and I'd have 3y equals 12. That thing's equation is a line. And I can just keep going, just picking out numbers for a, b, and c, fractions, negatives, decimals. As long as I don't put zeros in for both a and b, I'm going to end up writing an equation that when I plot out all the solutions to it would end up being a straight line. All right? So that's called the standard form of a linear equation. Something times x plus or minus something times y equals c. That's the standard form of an equation. Now, before I get on to example 1, which is where we're going to graph another linear equation by plotting points, I need to kind of remind you of a couple terms that you learned back in Algebra 1 that you might have forgotten about. And it's called the x-intercept and the y-intercept. And these are both related to each other. The x-intercept is it's a part of a line. So the x-intercept of a line is the point that's on that line where the line crosses the x-axis. Right? So if I scroll up here for a second and I look at this line that I just graphed, you can see there's a point right here where this line is crossing over the x-axis, which we remember is the horizontal axis. So that point right there, that is the x-intercept. Now going back down to my definition, if a line crosses the x-axis at point A, the coordinate of the x-intercept would be a, comma, 0. Because when we're crossing the x-axis, we are at 0 in terms of y. We haven't gone above or below where we started, right? So if it crosses at A, the x-intercept is a, comma, 0. And when we look at the y-intercept, it's kind of the same thing, but just changed to y's instead of x's in all these places. The y-intercept of a line is the point at which the line crosses the y-axis. So again, looking up here at this graph I have, you can see there's a point right about there where this line is crossing over my y-axis. That point is the y-intercept of that line. Just like I said before with the x-axis, if a line crosses the y-axis at point B, then the coordinate of that y-intercept is 0, comma, B. It's 0 for an x-coordinate because we haven't, at that point where we're crossing the y-axis, we haven't moved left or right from the origin, from where we started. We just went straight up. So its x-coordinate is 0, but its y-coordinate is something other than 0, perhaps. It's whatever this value is right there. All right? So let's graph this line by plotting points. And the reason why I wanted to tell you about x-intercept and y-intercept is because sometimes those are the easiest points to plot. All right? Sometimes finding the x-intercept and the y-intercept can be enough to plot a line. Of course, we need at least 2 points to plot a line. It's usually a good idea to find 3 so we can make sure that they all line up. So, because if one of them's kind of off and wonky, then it tells us we made a mistake because this thing should all the points should line up on this. So let's put in a 0 for x. Let's say 3 times 0 plus 4 times y, whatever y is going to be, equals 12. Let's figure out what that would have to be. Well, 3 times 0 is going to turn into a 0. That's why finding the x-axis, or I'm sorry, the x-intercept and the y-intercept is easy sometimes, because we put zeros in for x and y, and then they kind of go away. So that's going to be a 0, or a gone. 4y equals 12. That would mean that y would equal 3. So we put in a 0 for x, and we found out that the corresponding value for y would be 3. So 0, comma 3 is one point that I can graph. All right, I know my line goes through that point right there, 0, comma 3. Now let's do the same thing for y. Let's go 3x plus 4 times 0 equals 12. So now I just put a 0 in for the y. And so you can see that's going to go away, and I'll have 3x equals 12, which would mean that x is 4. So the point 4 for the x, comma 0, which is what I used for the y, that's also on my line. There's my see, so that point was my x-intercept because it's going where it's telling me where the line is crossing the, I'm sorry, that point is the y-intercept because it's telling me where the line is crossing the y-axis. This point right here, 4, comma 0, there's my x-intercept. Now I know if I connect these two, that should be my line. But just to make sure I didn't make any mistakes, let's try another one. Let's pick another value out for x and y and see if I can figure out another point on this. What if I put in, let's just put in, let's put a 2 in for y. So what, comma 2 would be a solution. So 3x plus 4 times 2 equals 12. Oh, I can tell already this might not come out very nicely. 3x plus 8 equals 12. Subtract the 8 from both sides. 3x equals 4. So x would equal 4/3. Now 4/3 is 1 1/3. So let's see if we can plot that. We'll go 1 1/3 and up 2. Does that look like it's in line with the other two? Yeah, it sure does to me. Looks like those are in line. So I think we're okay. I think we're in business. Now what we'll do is we will connect our points, and that should be our line. Okay, I'm out of time for this part of the video, so this is going to have to be a 2-part video, so join me for part 2 in just a few minutes. We'll see you then.